to projects. In this video, we are going to discuss about the project, which is machine learning models for classification of human emotions using multivariate brain signals. So before getting into the execution, first let's understand what is the project about. So coming to the emotions, humans have ability to control and alter their facial expressions, voice tones, and body language to convey their emotions that may not accurately reflect their true emotional state. So, this difference between external expressions and internal feelings can be intentional, as people often mask their true emotions to adhere to social norms, protect themselves from vulnerability, or manipulate a situation. As a result, relying solely on observable physical cues to judge someone's emotional state can be misleading. So, for example, someone might smile and appear happy in social situations despite feeling sad or anxious internally. Similarly, a person might maintain a calm behavior while experiencing anger or frustration. So, this is challenging to accurately assess emotions based solely on physical appearance, as outward expressions do not always align with internal emotional experiences. So, due to this limitation, there is need to explore two other alternative methods for emotion detection that are less prone to consciousness manipulation, that is, conscious manipulation. One such approach is the use of electrocardiograms, that is EGG signals. So these EGG signals, they are direct indicators of brain activity and they are less likely to be consciously controlled or masked by the individuals, offering a more reliable means of assessing true emotional states. So what are we going to do in this project is we are going to develop an automated system by using electrocardiogram signals, that is EGG signals, and we also use some machine learning algorithms to recognize these that is emotion recognition. And how are we going to implement this project is first we explore EGG signal images, that are electrocardiogram signal images, and then we visualize those images and do some basic pre-processing. So after pre-processing, next we train some machine learning models on the process data. So we used LSTM, BiLSTM, ANN, SVM, and KNN to recognize these human emotions. So we'll be training all of these models on the pre-processed data. And we use some evaluation metrics that are accuracy, precision, recall, and FN score, and evaluate all the models built and select the best performing model, that is, which gets the highest accuracy. And then we select that model for deploying it in the front end for emotion recognition. And we build front end using Flask framework with SQLite. That is, Flask framework is integrated with SQLite for user testing with the user authentication. And this project, it serves researchers in neuroscience, psychology, along with the practitioners in human computer interaction and mental health. And this project's primary objective is to create a precise emotion recognition system utilizing EGG signals. So, this advancement aims to elevate user interaction experiences, enhance mental health monitoring, and contribute to the exploration of human emotions and behavior. Moving on, we have used all these algorithms to train the human recognition model. So, we used LSTM, BiLSTM, ANN, SVM, and KNN. So, we built all these models for recognizing the human emotions. Among all the models built, we found that SVM is achieving highest accuracy, so we chose it for deploying it in the front end. Moving on to implement this project, we need software and hardware requirements. So coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And moving on to the hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now let's execute the project. So to execute the project, we need to open the code folder which contains source code files. So these are the source code files in code folder of a project. Let's understand each of them. How will they be used in the project? So in the first folder, which is dataset folder, we have EEG signal images in it. So open the dataset folder. Here we have two more subfolders. One is negative and positive. In negative folder, we have images related to negative emotion. So we'll be using all of these EEG signal images for training the models. Coming back here in the positive folder, we have images related to positive emotion. So we'll be using all of these images to train the models to recognize the emotions. So what are negative emotions are? They include sadness, anger, fear, and anxiety. When the system detects patterns in the EEG signals that correspond to these type of emotions, it categorizes them as negative. Moving on to the positive, these include feelings such as happiness, joy, excitement, and contentment. So, when the system identifies EEG signal patterns associated with these emotions, it categorizes them as positive. So, get back. Moving on to the static folder, this folder contains files related to project styling and interactivity. They include CSS, JavaScript, and Bootstrap files. So these files they are crucial for enhancing visual appeal and functionality of the project's web interface. The next folder we have is templates folder. Here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides the structure and layout for displaying content to the users. Moving on to the test cases folder, here we have some of the EGG signal images. So we'll be using all of these images as the test cases in the front end to detect the human emotions. So now get back. Moving on to the app.py file, this Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And this is the model file which contain the algorithm information, and this will be loaded into the project code during runtime. And here we have notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And the last four are also the model files. And this is the signup.db file. This file is a database file which is used to store the user information. So we understood all the files. Now let's execute it. Now copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and then click on enter. So this current directory is changed to the code folders path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here and now click on enter. So this is the web page of the project, which is displayed in the browser, and this web page is developed using Flask framework. So to execute it, we need to log in. So click on login and enter username and the password. If you are signing, that is if you are signing in. If you don't have an account, so click on sign up and enter all the credentials and click on register. As I already have an account, I'll directly sign in. So click on sign in, give the username and the password. I have entered my username and the password. Now click on login. We are redirected to the prediction page. So here we can see a choose file button. We need to click on that for uploading the EEG signal images. So click on choose file. Here we have some of the images that are some test cases related to EEG signals. We need to upload these images to recognize the human emotions. So let's upload the first image. Click on open. Here we can observe that image is loaded. Now click on upload. And here we got the prediction for the given input image as negative emotion detected, which means that the person he may be sad, angry, afraid, or anxious. Let's upload some more images and predict the human emotion. Click on try again. Click on choose file. Let's upload the second image. Click on open and now upload it. So here we got the prediction for the given input image as positive emotion detected, which means that the person may be happy, joyful, excited. Let's upload some more test cases. Click on try again, click on choose file. I'm uploading the third image, click on open. Now upload it. So here we got the prediction as negative emotion detected. Let us upload one more. I'm uploading the fourth image. And here we got the prediction as negative emotion detected, which means the person is sad. Let's upload some more. Click on try again. Click on choose file. Now we'll be uploading this image. Click on open and now upload it. And here we got the prediction as positive emotion detected. Let us upload last one more image. Click on try again. Click on choose file. So I'm uploading the last image. And here we got the prediction as positive emotion detected. In this way, just by uploading EEG signal images to the system, it will detect the human emotions. Now click on sign out. This project successfully demonstrated the development of a reliable emotion detection system using EEG signals, addressing the limitations of traditional methods that rely on physical cues. By leveraging advanced machine learning models and evaluating their performance using comprehensive evaluation metrics, the project achieved high accuracy in classifying emotions into positive and negative categories.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.